In this lesson, we'll do few more questions for better understanding of arithmetic progressions. Here we are given a sequence. Given sequence is 5, 2, -1 and so on. This is -85, but we don't know which term is this. So if the 5 is first term A1, 2 is second term, -1 is third term, we have no idea. Let's call this as AN. And we will be interested in finding N. Which term of the sequence is -85? So if first term of the sequence is denoted by A is equal to 5. Common difference, which is denoted by D, can be obtained by subtracting first term from the second one, A2 minus A1, that is equal to 2 minus 5, which is equal to -3. So we have common difference, which is -3. First term is 5, and AN, the last term or the nth term, is given that this is -85. What we are interested in finding is the number which term is -85. So we will be interested in finding N. If we look at the formula for nth term of an AP, since AN for AP mean nth term of arithmetic progression is AN equal to A plus N minus 1 into D. This formula contains all of these, A as well as N as well as AN and D. 3 of these unknowns are given that their values there is known, and 1 is unknown, and in such a case this formula is ideal. So AN, which is -85, let's write down the value. -85 is equal to, for A we can substitute 5 plus N we need to find out, into D. For D we have -3. So other than N, everything in the formula was known, and we can find this value -85 equal to 5 minus 3n, and this is plus 3 because -3 when multiplied gives us -3n plus 3. So -85 equal to -3n plus 8, and now we can transfer all the terms independent of n to the other side of the equation. This gives -85 minus 8 equal to -3n, and now if we divide both sides by -3 for finding value of n, this will be -93 over -3, and that should give us the value of n equal to 31. So this is the value of n, means that 31st term of the sequence is -85. So 31st term of sequence is -85. Now let's do this next question. For next question, we are given that L, M and N are the pth, qth and rth term of an AP. So pth term AP is given that this is equal to L. Qth term is given that this is M, and rth term is given that this is equal to N. This means if pth term is equal to L, this means that A plus P minus 1 into D, that's pth term, is equal to L. And let's call this as equation 1. And if AQ is equal to M, it means A plus Q minus 1 into D is equal to M. Let's call this as equation number 2. And similarly, A plus R minus 1 into D is equal to N. And let's call this as equation number 3. If we carefully examine the question, the relation which we need to prove is independent of A as well as D. A and D doesn't appear in the relation that we need to prove. So from equation 1, 2 and 3, somehow we will need to eliminate A and D. Keeping that in mind, we subtract 2 from 1. That way we will be able to eliminate A. So subtracting 2 from 1, that should give us A plus PD minus D is equal to L, and this is A plus QD minus D is equal to M, and if we want to subtract, we got to change the signs. And by doing that, what we get is that A gets cancelled with A, that was the objective, minus D gets cancelled with plus D. So what we have is PD minus QD is equal to L minus M. If we take D common, this would be P minus Q times D, and that would be equal to L minus M. Let us call this as equation number 4. Similarly, if we subtract 3 from 2, we will have Q minus R. Similarly, if we subtract 3 from 2, that way we can eliminate A's again. So that will be Q minus R into D is equal to M minus N. Let us call this as number 5. From relations 1, 2 and 3, by subtraction we have eliminated A, but D is still there. In order to eliminate D, if we divide 5 by 4, for eliminating D, 5 by 4. So if we just do that, we'll have P minus Q into D divided by Q minus R into D equal to L minus M over M minus N. This way we can eliminate D. What we are left with is P minus Q over Q minus R is equal to L minus M over M minus N. Now cross multiplication will give us P minus Q times M minus N is equal to L minus M times Q minus R. Always during this process of simplification, keep an eye on the relation which we want to prove. So let's multiply this. This will give us Pm minus Np minus Mq plus Nq is equal to Lq minus Lr minus Mq plus Mr plus Mr. See if we can cancel anything on both sides. Minus Mq and minus Mq can be cancelled. So now if we take common P from the first two terms, and before we do that, let's move all the terms on the left hand side of the equation. Pm minus Np plus Nq minus Lq plus Lr minus Mr equal to 0. And here if we take P common, this would be M minus N plus Q common, that would be N minus L, and R common will give us L minus M inside equal to 0, which is required, which was required. And let's do the last question. And for the last question, we are given that if 1 over A, 1 over B, and 1 over C are in AP, then B is equal to 2AC over A plus C. So for question number 3, if 1 over A, 1 over B, 1 over C are in AP, then what is the criteria for a sequence to be AP sequence? The criteria is that the common difference is same. This means if we subtract A2 minus A1, that is going to be same as A3 minus A2. This means that 1 over B minus 1 over A is equal to 1 over C minus 1 over B. So keeping that in mind, now let's take LCM on both sides. This would be A minus B over AB is equal to B minus C over BC, and if we cross multiply, this would be BC into A minus B is equal to AB times B minus C, and if we multiply both sides, this would be ABC minus B square C is equal to AB square minus ABC, and we can bring ABC on one side. So this is ABC plus ABC is equal to AB square plus B square C. This means 2ABC is equal to B square into A plus C. And from here, if we cancel out B from both sides, this will leave us 2AC is equal to B times A plus C. This means B is equal to 2AC over A plus C, which was required, which is required. So this way, using this property of common differences being same, we can prove any relation that is given in question.